Here, we are tasked to solve the derivative of the given function at z equals 2 using the definition. By the way, since in the previous video, we're able to identify already the derivative of this given function using a definition, allow me to copy that here because this is just the part 2 of that specific item. That video contains this page. We're able to identify the derivative of the given function 1 plus z all over 1 minus z using a definition. We had all of these processes that allowed us to reach an item equivalent to this 1 minus 2z plus z squared, or could also be written previously as 2 over, you have here 1 minus, you will have z squared, if I'm correct. Yes, that's also its other form. So either way, they are just the same, but since the previous video provided us with 2 over 1 minus 2z plus z squared, allow me to use that here so that our video at this time, only for the value of the derivative when z is equal to 2, is now shorter. So that would mean that if you are not yet convinced with the derivative of the given function, 1 plus z over 1 minus z, which yielded 2 over 1 minus 2z, if I'm correct, 2z plus z squared. Again, let's return there. All right, that's correct. Right. So try to review that specific video if you're not yet convinced with this being a derivative. Okay, the video is in this playlist. Try to browse that and watch that on your own time. At the same time, take note the derivative that we had in that specific video, and this one here was actually developed or determined using a definition. If you are familiar and comfortable with the rules of differentiation, you can also use that to determine the derivative. Because when we use this one, at z equals to 2, we can just simply substitute here f prime of 2 because this is already the derivative. That would mean the result here is 2 minus 1, all over 1, minus 2 times 2 being our z, plus our z, which is 2 squared, which will give us 2 over 1 minus 4 plus 4. This is just actually 2 over 1 because this is 0, giving us the result of 2. In short, the derivative of the given function at z equals to 2, regardless of whether it uses the definition in finding derivative or the rules of differentiation if you would like to, the answer is equal to 2. I also mentioned earlier that this derivative could also be written in this because usually if you're using the rules of differentiation, you will come up with a square of a binomial in the denominator, especially if our function is a rational function. Even if you're going to use that and say you will be using 2 over 1 minus z squared, you will still get 2 over 1 minus 2, which is 2 over negative 1. The square of that, you will have 2 over 1, which is still equal to 2. So this is the reason why we're doing this, just to connect it to the previous video, to make it even shorter, just to make us understand that if we're going to solve a derivative at a given point, get the derivative first, whether by definition, in this case by definition, or rules of differentiation, and use that value of z later on in your first derivative to get the value. Thank you very much for watching.